All right, guys. So 1.4, we're dealing with polynomials. So polynomials, you'll notice, have a bunch of different things. They're not just numbers, but they may contain letters, they may contain exponents, and we're going to get used to a few terms here that you may or may not remember, or for some of you, it might just be a little bit of a refresher, okay? So we're dealing with like terms. So like terms are terms that have the same variable and raised to the same exponent, okay? And what that means, you might forget what a variable is. A variable is just a letter that's attached to, say, a number, okay? So in this case, we usually call this the coefficient or the numerical coefficient. And this is what we call our variable or literal coefficient. Okay, and an exponent, as we know, if we have a number, it's this superscript up top, which is our exponent. So for a term to be like, they can have different numerical coefficients, but they must have the same variable and they must have the same exponent. Okay, so if we look at the terms 5x, 7x, and 25x, well, they're all different numbers, which is fine, but they all just have x. They don't have x squared, x cubed, all these different letters or numbers in there. They're all like terms because they share that x, okay, with the same exponent, or in this case, lack thereof exponent. But the next example is 4a squared, 8a, 6p, and 30xy. And they are unlike terms, okay? Or they're just different, okay? They're different terms. They're not like terms, okay? So if we continue on the following here, it says circle or underline the terms, the like terms. So I'm going to just highlight, and hopefully you guys get a good grasp on this. But if we look at all these, we have 5b, 6g, 17gh, negative 7g, 12g squared, negative 6ghg, negative g, and 10g. Well, if I look at it, remember we can have different numbers, but if the variable and the exponent are the same, then they can be like. So in this case, I saw a 6g and a 10g. Those look really similar. But we also have the negative 7g and the negative g. Unfortunately, we can't use that 12g squared, which seems similar, but it isn't like due to the fact that it doesn't have the same exponent. It's got an exponent of 2, where the others do not, or they have an exponent of 1, okay? If we look at the next grouping, we have 8m squared minus 9m, 3m squared n, negative 10m squared, 14m squared n squared, m squared, 8m, negative 6mn squared. Whew, that's a lot of stuff there. Now, if I look around, once again, negative 9m and m, they have different numbers but the same exponents. Trying to see if there's any others here that might make sense. Well, we actually have another one, which is 8m squared, and we have negative 10m squared. If I continue to look, that 3m squared n looks very similar to the negative 6mn squared. However, the squared here and the squared here are on different terms, so they are not like terms, okay? So those would be our only like terms. Sorry, I missed this one here, m squared as well, that we have. So we've got 9m and 8m, then we have 8m squared, negative 10m squared, and m squared, okay? Whew. Now we've got a couple others. For our next one, we have x squared y, 16xy, negative 9xy squared, 72x squared y, negative 18x squared, 29x squared y, 35y squared, and negative 3y x squared. So this one right off the bat, I'm just going to change it to this because we always want to keep these in alphabetical order, and y comes after x. So if that's the case, I know we've got a couple right off the bat. I saw there was an x squared y. I see there's another x squared y and another one right here and one more at the end there. Now, we have an xy, but we don't have any others. We have an xy squared, but we don't have any others. We have an x squared, and we have a 35y squared. So none of those are like other than the ones that I just did there for us, okay? So those would be your like terms. Now we deal with collecting like terms, and if we have multiple of them, we can just add them out, all right? And collecting like terms, once we do that, we'd write them all out and then collect them. So in this case, it's probably easier just by doing, we have a plus a plus a. That does not mean a to the power of 3. What that means is that we have 3 a's, so it would be 3a. Okay. Now we have b plus b plus b plus b plus b, so we have 5 b's, so it'd be 5b. All right. Now we've got some different ones here, which we have to really work with. We can't just combine these two, so we're going to take the y's. We're going to keep the g's separate. So we have 2y, so y plus y is 2y. Then we have g plus g plus g plus g being 4g. Okay. Now, for the next one, what we need to do is we're going to add the numerical coefficients here in this case. All right. So we've got 2a plus 5a. Well, the a's are the same and the base stays the same, but 2 plus 5 is 7a. All right. And the next one here, pretty similar to the last example, we have 3b plus b. If it's just singular, it's like we have a 1 in front of it. So 3 plus 1 being 4b. All right. And when we collect them, we want to write them beside each other and reorganize it. So for instance, this one, we have 3y and positive y, and we have 2g and 4g. So if we did 2g plus 4g, we've organized our g's. And we have 3y plus y, we've organized our y's. So 2g plus 4g is 6g, and 3y plus y is 4y. So you see how we've reorganized that to make sure that the y's are in one area and the g's are in the other. So that's what we mean by collecting like terms. For our next one, we have all t's, except the numerical coefficients are different. So we just add those coefficients. So 4 plus 7 is 11, plus 3 is 14, plus 1 being 15t would be our answer. Could everyone just do me a favor and throw a thumbs up if this is making sense so far? Just throw a thumbs up if you could. Awesome, guys. I don't want to lose you at this point, okay? So we're getting real close with this. And now we've got one that's a little trickier because we have m's, like they're all m's, but one is an m and one is an m squared. Remember, they need to have both the same variable and the same exponent. So these are not the same. So m squared and 7m squared are going to be together, and then our m's are going to be together. So 3m squared, if we rewrite it, plus 7m squared plus m plus 4m. And if you're one of those people that when you rearrange, you get a little confused, just as soon as you write it down, just cross it out. So if I wrote the 3m squared, then I wrote the 7m squared, then I wrote my m, then I wrote my 4m, I make sure that I took care of all of the terms. So 3m squared plus 7m squared, we add the numerical coefficients, which becomes 10m squared. Then we have m plus 4m becoming 5m. All right. Last two examples, guys, and we're almost done. We already kind of have them grouped. We got the q's here, and we just have numbers over here. So 7q plus 15q, well, 7 plus 15 is 22q. And then we have 25 plus 10 being plus 35. The next one is where things start to get confusing. So we have 10y squared z plus 8z plus z plus z, 5zy squared plus 6z. Remember what I said about making sure that things are in alphabetical order? So make sure that we don't have that happen. So we just redo it or rewrite it like that. And when we do that, we can actually see that we have some like terms. So we have that 5y squared z, the 10y squared z. We also see that we have the 8z, the z, and the 6z. So we can just go ahead and put those together. So we have the 10y squared z plus 5y squared z plus 8z plus z plus 6z. So 10 plus 5 being 15y squared z plus 8 and 1 is 9 plus 6 being 15z being our final answer.